Hi everyone, in this episode we're going to do electricity. So electricity, right, in most of the SPM years, it has always been a very high mark punya chapter. Of course, combo with electromagnet and electronics. So if you ask me what chapter is very important for SPM, I will always say electricity. So today, let's start from a Percubaan Negeri Sembilan for 2024. Now remember guys, you can actually download this file in the description below and you can write with me because I bet most of you have an iPad or have a tablet, so we can do our writing and practice together. Okay, so the first question is an air fryer question whereby they ask what is the meaning of the label of 240 volt and 1.5 kilowatt. Okay, so you always have to remember if kilo, right, we'll try to break it the kilo first, so it becomes 1500 watt. So 1500 watt, how can we break this into smaller parts? Okay, so we know that watt is actually a power. So power is actually equals to energy over time. So watt is actually joule over seconds. So watt is joules per second. So JS negative 1. Now, so if you ask me what is the meaning of label of this, so usually how we will answer this question is that we will say that the air fryer, so I will start with the name of the electrical appliance, uses or it requires. So now we break this 1500 joules, 1500 joules of electrical energy. So we use the joule then per second. So we will say in every 1 second when connected. Okay, so now this is, okay, we already said about the 1.5 kilowatt. So provided that if this is connected to 240 volt of voltage supply, alright. So in your definition, most importantly, you have to talk about the joules in 1 second and when you provide 240 volts. So this is actually a definition question. Okay, so 3 marks. Then now the next question they ask, calculate the total electrical energy for the air fryer if you use 90 minutes per day. Okay, so recently, I would say the trend for question in electricity is that I feel like they would like to ask this kind of calculation. So I'm looking at the Perak State paper, punya this calculation, whereby we are looking at cost of electrical energy consumed. Okay, so what is there to learn here? Okay, you have to know that 1 kilowatt hour is actually the same as 1 unit of tariff electricity. So meaning to say that when you go outside your house, you see your meter run by 1, right? That means that you already use 1 kilowatt hour. Okay, so now if this electric kettle is used for 70 minutes per day for 3 weeks, how can we calculate this? So my strategy is always we take the power multiplied by the time taken first. So my watt, which is my power here, is going to be 1500 watt, okay? So power 1500 watt. What about my hour? So they say it's 70 minutes. So 70 minutes is actually 70 over 60, right? Because we want to find what is the ratio of 1 hour. So therefore, which is, or you can also write 1 to 1 over 6 of an hour. So it's just maths, okay? You take your total minutes divided by the 60 minutes, you get how many hours. So now we will take 70 over 60 to get our calculation in terms of watt hour. So I got 1750 watt hour. But remember, we are looking for kilowatt hour. So immediately I have to divide by 1000. So I will get 1.75 kilowatt hour. So please do take note on this. Alright, so this is always per day. So you can always write this is per day. But now we want to look for 3 weeks. So for 3 weeks, 1.75. So 3 weeks is actually equivalent to 21 days. So I'll take 1.75 times 21 days to get 37.5 kilowatt hour. So this 36.75 kilowatt hour is already for 21 days. So now my last step, I will have to take 36.75 units because 1 kilowatt hour is 1 unit, and multiply by the price of 218 cents. Okay, so if I multiply this, what do I get? So I will get 8 ringgit point 012. Okay, so as calculation, we will usually leave in terms of 3 decimal places. However, in this calculation, right, can I leave 3 decimal places? Cannot lah, because ringgit Malaysia where got 3 decimal places one. So maximum you can only get is 1 cent, right? So therefore, please don't write 3 decimal places when it comes to money. So with that, then only you get 2 marks. Okay, so quite leceh lah. Okay, you have to convert. You have to find watt hour first. This is your step 1. Then change it to kilowatt hour, your step 2. Then change it to the days. Then multiply by the price. Okay, so there's like 4 steps. Okay, to get the 2 marks. Okay, so this is the hot topic now, alright? So okay, let's go back and see our air fryer, okay? Now, so here we go back to our negeri sembilan question. So now, air fryer, your material of your heating element. Okay, so whenever we talk about all these questions, right, there's so many common mistakes. So why? Because every single time you have to think about your resistance first. Okay, resistance, you want high resistance or low resistance. Is high resistance always bad? No. Why? Because we will pick something to have high resistance. It's actually good if that thing needs to produce heat. Alright? You will pick this thing to have low resistance when this thing you tak mau produce heat, which means that you don't want any heat to be obtained. Okay? So now if you look at this is a heating element. So guys, heating element, you want heat or not? So this has to be producing heat, right? That's why it's called a heating element, right? So if you want heat, you're looking for high resistance. So my material of a heating element, I'm looking at a high resistance material. Okay, so in our syllabus, the 2 most common material that has higher resistance are nichrome. Okay, so which in this case, nichrome is the most commonly being used as a heating element. So that goes our SNT. And the other one that has high resistance is tungsten, whereby tungsten is usually used in the filament of your light bulb. Alright, so why? What's a filament? It's actually, if you see this is a light bulb, so this is the filament. This thing will have to produce heat in order for it to light up. Alright, so this one, you want panas, you want heat. Okay, so now I've already eliminated copper. So now the number of fan blade. So a fan, if you have more blades, you will actually be able to produce more wind, more air movement. So in this case, I will want more fan blades. I want nichrome. So my jawapan confirm is going to be S lah. Alright. Okay, so let's quickly look at this one. So the material of the heating element. So my choice here will be nichrome or nichrome. So why? How can we explain this? Okay, guys. If you write high resistance immediately, sometimes the schema jawapan don't want that. You are supposed to say that because it has high resistivity. Please guys, please take note that resistivity is not the same, alright? It is totally not the same as resistance. It is related, but it's not the same, because resistivity usually is referring to the material. So we need to say that it has high resistivity. Nichrome is a high resistivity material, so therefore it has high resistance, and since it has high resistance, it will be able to produce more heat. So to heat up lah, to produce whatever lah. So mainly it will be able to get more heat. Okay, so you see we talk about resistivity, then we talk about the resistance, then we talk about more heat. So I don't want to skip anything here because we won't know the schema, which is the word they are looking for. So the best way is we write complete answer. Okay, can? Alright. Moreover, this is, for some of you, if you don't do science, this is the last time you do physics, right? So you might as well just write your best answer. Okay, now what about the number of fan blade? So the number of fan blade, remember, don't say 12. We will say we want more number of fan blades. Okay? So what is the reason why we want more number of fan blades? Okay, it's because, so more number of fan blades will be able to produce more air movement. Okay, if you don't want to use so pattern punya air movement, you will be able to just say produce more wind to distribute the heat to cook your food evenly. Okay, now why do we use this word to distribute cook food evenly? Okay, because if you look at your air fryer, you will realize that, okay, imagine if I have the mangkok, right? So let's say I'm trying to fry something lah, cake whatever lah. Okay, why would I fry cake? Okay, you will see that the heating will only be done at the top, correct? But in reality, right, you want the wind to actually distribute the heat so that the heat can actually surround your food, okay, surround every part of your food so that it will be cooked evenly, not just the top part because the heating element is on top, alright? So that's why oven, most of those cooking food, you have the fan to distribute the heat. So ultimately, our choice is going to be air fryer S. Okay, Ken, alright? Now, so we are done with the first question already. It's just a very short question. Now, we are going to look at the second question. For second question, we are going to look at Penang Set 1. Okay, this is actually an essay question. Now, so this is an electrical circuit whereby they show you this whole entire thing and then they ask you what is the function of the rheostat in the circuit. Okay, why I want to do this question is because I realized that for this year punya state paper, rheostat quite common question. Alright, rheostat is also known as, there's another name whereby they call it as a variable resistor. So I give you this name, you will agak-agak know what is a rheostat. Alright, you can change the resistance one. So what's the function of the resistance here? So some people will just write change resistance. That's not the real function, okay? Okay, so I will say that the real function of the rheostat is actually it is able to control the magnitude of current, okay? For people who don't know, so usually my style is when we write current, we'll try to say magnitude of current, or to control the current flow, magnitude of current flow by changing its resistance. Okay, so if you change the resistance of the rheostat, you'll be able to control the magnitude of the current flow. Okay, Ken. Okay, state the energy transformation that occurs at the bulb. So for your bulb, so bulb is what energy masuk, what energy keluar. Okay, so obviously the energy that's going in is going to be electrical energy. Okay, I write electrical E. And then what will come out? Alright, so you can say that there will be heat energy and light energy. Or another way that they accept is also you can say that there's heat energy because your filament lights up, right? Then it produces the light energy. Okay, so both are acceptable depending on what is your understanding lah. Okay, technically you can't argue which is correct, which is wrong because both are acceptable. Okay, Ken, alright. Okay, so once we are done with this thing, okay, we're already done with this one mark. Okay, then we will talk about how to draw by using symbols. So, what are the common mistakes? Okay, look at the battery, guys. So the positive is on the right hand side, the negative is on the left hand side. Okay, you can see, right? So when I draw, make sure that the longer ones are on the right hand side because that is your positive light. The long line is your positive light. Then we're gonna draw the way down to my light bulb, all the way to my rheostat. So rheostat usually is a rectangle with an arrow, with my switch, and then back to my light bulb. Okay, so this arrow you have to draw like this lah. So that is my rheostat, that's my bulb, battery. Since got 2 battery, you draw 2 battery. If 3 battery, then you draw 3 battery. And then 1 switch only, that's it. So of course the marks here are not a lot. Why? Because it's only 1 mark, so tak susah pun. Okay, now then they ask why the brightness of the bulb increases when the slider is adjusted close to Q. Okay, So we talk about this question now. This year, right, for 2024, I've got a feeling now. Okay, resistance will be a hot topic. It will be a hot topic whereby what affects resistance. So like for example, in Selangor punya state paper, they actually forced the students to calculate R equals to rho L over A. So which I think this is actually very good. It's a very good thing to force students to do. And then after that, because you need to know that when your length increases, your resistance will increase. But when your cross-sectional area decreases, your resistance increase. So your length and your area terbalik punya. Length longer, more resistance. But if your cross-section area bigger, lower resistance. Why? Because now more current can flow ma. Faham? Okay? Now, so let's try to find, sometimes if you think it's very difficult, right? Like when you're stuck in exam, right? Try to look for clues in the question. Okay, they tell you the brightness of the bulb increases. So what caused the bulb to increase in brightness? So obviously the first mark that I'll show you say, oh, because the magnitude of current flowing into or across also can into the bulb actually increases. So the magnitude of current flowing into the bulb increases. What's next? So if your current starts to increase, then why? So because when you change the slider, we will say that the resistance of rheostat actually increases. So why it increases? Because most likely the length of wire in rheostat decreases as the slider slides to Q or towards Q. Okay, so they actually use this slider to control how many wires that your current will flow. Alright, so more coils that your current flow, the longer the wire, the higher the resistance, the lesser the current. From this info we see, we know that the current increased already. Oleh itu we know that the resistance must decrease. So if the resistance decrease, obviously the length of wire has to decrease because resistance and length is directly proportional. Alright. If you ask me, teacher, you see here, you boleh nampak is it more or less? Okay, here is very not obvious to see. Okay, so how I know that it's decreasing? Because I use the question punya tips. Brightness of bulb increases when the slider is adjusted. Okay, the brightness of the bulb increases when, so therefore the brightness is current resistance affect the length. So this answer will be perfect. Okay, now then we go into series and parallel calculation. Okay, I wish I want to do series and parallel calculation, but I think that one will have to be another one very long video specifically on calculation. Okay, now however, let's have a look here. Okay, this one is not difficult. Why? Because you want to find what is the total current flowing in the circuit. So to find the total current flowing in the circuit, I realized that this is a parallel circuit whereby it is split into two different jalan. Okay, so if I can find I1, if I can find I2, I will be able to find the total current. Why? Because current is like number of people. If you got 10 people keluar from sini, if I know that 2 people will turn left, the total people that will go down will obviously be 8. So if 10 people keluar, 2 people turn left, go straight confirm 8. Because you have to total back to the total number of people here. Okay, so now let's try and calculate what is my I1 value and I2 value. How can we do this? Okay, I realize that this is power. I realize that this is V. I realize that this is power. I realize this is V. I can use something what we call P equals to VI to actually calculate this. Okay, so how? So we know that, okay, let's just count this first. So P equals to VI. My power is 3, my volt is 6, my I. So I realized that my I is actually 0.5 ampere. And then after that, P equals to VI. So my power is 12, my voltage is 6. So my current is actually 2 ampere. So this sini, you will realize that this is 0.5, this is 2. So when I want to calculate what is the total current, so all I have to do is, I just have to take 0.5 ampere plus 2 ampere. So I will be able to get 2.5 ampere. That's it. Okay, Ken? Alright. So what? 3 marks, you know. Why? Because they give you marks for this calculation, and this calculation. So 3 marks. That's it. Okay. Next, what about the energy used in the bulb R in 1 minute? So which is this bulb R. Okay. So how do we do this? Very simple. I don't need to use very fancy formula. I can use back what I've taught you since the first minute of this video. You will realize that P is equals to E over T, power's energy over time. For bulb R, we already got the power. The power is actually 3 watt. So meaning to say that if my power is 3 watt and I want to find dalam 1 minute, so the only trick here is you have to change it to SI unit, guys. Come on. Remember, time you must change to seconds, and then temperature you must change to Kelvin, especially for gas law. So please be very careful. So your power here is 3. Then your time taken here is 60 seconds. This is energy. So if I times up, my energy will be equals to 180 joules. Okay, so the energy used here will be 180 joules for 1 minute. Alright, so that's it. The 2 marks calculation is very straightforward. It's very simple one. Okay, so no problem, right? So far so good. Okay, then we go into our essay question. Okay, so this essay question is quite interesting, because now they are talking about this thing called the National Grid Network. Okay, what is a National Grid Network? So this whole diagram 10.3 is actually telling you that in Malaysia, right, it's this one. So first, we got the generator. So the generator will actually produce the electricity. Okay, will actually produce the electricity. And then your generator will go through something what we call the P transformer. Okay, then go to the big punya National Grid Network pylons and everything. Then you got Q. And then after that, then only go to U. Alright? Okay. So now, what is your transformer P and what is your transformer Q? Okay. So jom kita pergi tengok next page. Okay. So this is our concept. Okay, when we send electricity, do we want to send at high voltage or low voltage? Okay, so fun fact, guys. Now in this wire, biasanya the voltage is about 33,000 volt, and your house only requires 240 volt. So obviously, this is going to be a step up transformer. This is going to be a step down transformer, because you have to increase the voltage, and then after that later you have to decrease back the voltage. So oleh itu my P has to be up, Q has to be down. P has to be up, Q has to be down. So K and M already been eliminated. Alright. Now however, guys, I'm not going to explain to you why this one have to step up, why you have to increase the voltage. Okay. Now, if you think you know the answer, alright, I challenge you guys to comment below why when we transport or when we transfer energy, why do we purposely increase the voltage to make it to become very, very high voltage? So what is the reason? Okay. So now, okay, we will say here that this is to increase the voltage, then to reduce the voltage, to increase the voltage, to reduce the voltage to the user. Alright. And then after that, you will see that now this one is transmit with low voltage, this is transmit with higher voltage. So Jung Hao just said, right, when we send voltage, we want to send high voltage. How to explain? Okay, we'll see anybody be able to drop me a message, a reply at the bottom, and then we will like his comment if he gets it correct. Okay, so therefore, current with high voltage, you have to step up when you send. Then lastly, what about the diameter of the conductor cable? Okay, so when we talk about diameter of the conductor table, we are talking about this diameter, correct? Which is related to your cross-sectional area of your wire. So your conductor cable wants to become hot or not? Need to become hot or not? So the answer is no, because the purpose of your conductor is just to send electricity, just to send electric current. Don't want to produce it. So your conductor tak mau heat. So if tak mau heat, we are looking for low resistance, meaning to say that we are looking for thicker wires. Alright. So I want a bigger diameter of conductor. Alright. So why? Okay, how do we explain this? Okay, I'm just going to write down here. So a bigger diameter means that you will have a lower resistance. I don't have to explain resistivity because this is not material. Resistivity is material, okay? So lower resistance so that it will produce lesser heat energy lost to surroundings, meaning to say that you actually lose lesser heat energy to the surroundings. So means that it's higher efficiency. Okay, now please guys, I just want to menyeru you all. Don't just straight away throw an answer, say like higher efficient, more efficient, higher efficiency. Okay, because when you say something is efficient, right, unless you explain it why, like for example, because a thicker wire has or a bigger diameter wire has lower resistance, produces less heat, so it makes the system more efficient. Your more efficient is a conclusion, it's not the point. Okay, so sometimes you see some answer that you say, oh, more efficient. It's not a good answer. Alright, you have to tell me the facts. Okay, so produce lesser heat energy. So therefore, why? Because it has lower resistance. Then you can say more efficient. Okay, lastly, so we want it to be on the pylon. Okay, what is a pylon? So pylon is the cute tiang that looks like some Eiffel Tower thing that actually hang all the wire. Okay, so why pylon? So pylon is usually stronger, and it also allows, you can say, the wires to be hung higher. So therefore, it is safer for for road users or for pedestrians or anything, because we want the wire to be very high so that you won't accidentally touch the wire. If you accidentally touch the wire, you will die instantly, you know, because this thing is actually like 33,000 volt. Okay, or even higher than that. Okay, or you can even say that pylon is actually stronger structure that can support the weight of the wires. Because your wires are metal, so metals are heavy. If it's concrete pillar, maybe tak cukup strong to support. Pylons are metal, you know. Okay, Ken, alright. Now, so this is the essay. So my choice here is going to be L. Okay, let me remind you on something, okay, which is this year punya another special question that might come up. Let's have a look at Kelantan. Okay, so Kelantan has this thing on whereby there's a candle flame, and then after that there is a candle flame drawing. Okay, so this subtopic, right, which actually touches on the we call that as electric fields. So this is a topic whereby Suda quite long never asked before. Okay, so you might want to be a bit careful. Now in electric field, there are generally two things that you have to be very careful, which is number one, your candle flame that you make sure you have to study, and also another one more on the ping pong ball. So like the oscillation of the ping pong ball, you have to know how to draw, you have to know how to explain, you have to know how it works. Alright, lagipun electric field also has a formula calculation one, you know. So we actually have a calculation whereby E is equals to F over Q. E is also equals to V over D, whereby force per unit charge, voltage per unit distance. So this is your electric field strength, whereby electric field strength can be Newton per charge, ataupun volt per meter. Alright, so this is something that if you don't really go and study, you might overlook it. Alright, okay, so if you see this sample question, they say a 2-coulomb charge is placed in electric field, experience an electric force, calculate the strength of the electric field. So what you're gonna do right now, very simple. E is equals to F over Q, right? Correct? So your force now is, this is in kilonewton. So if I were to times 1000, so it'll be like 1, 2, and 3. This is actually 3.2 Newton. And then after that, the column is 2 coulomb of charge. So I'll get 1.6 Newton per coulomb of charge. Itu saja, guys. Very simple. Alright, so yeah, not very complicated. And give you 3 marks. Why 3 marks? Is because it is better to show that when you times 1000, you get 3.2 Newton. Okay, because 3 marks, so I decided that I want to show this step. Okay, Ken? Alright. Okay, so bonus question. One more bonus question. Okay, if you see this question, which is on the explain 4 marks essay, is always students punya biggest weakness. Okay, I'll give you 5 seconds to read the question first before we continue. Okay, now, so explain the concept used in connecting wires to ensure the electric kettle can function more efficiently. So, connecting wire, guys, your connecting wire wants to produce heat or not, needs to produce heat or not. So let's have a look. Okay, imagine I have an electric kettle. So if you tengok this thing, right, the inside punya thing, right, this is actually called the heating element. Alright, that is actually called the heating element. This one, the black color one. The outside part, this is actually called the connecting wires. So we got element inside dalam, wires outside. The element is the one that's going to be connected to the water lah. Alright, Ken? Okay, so explain the concept used. So for connecting wire, this one don't want heat because that is the outside. Inside, which is connected directly to the water, this one you want the heat. So you need to be able to distinguish when do you want the heat, when you don't want the heat, when you want the heat, when you don't want the heat. Okay, so because wires don't want heat, right? So obviously I want this to have, common sense lah. Okay, low resistance. So what kind of physics concept can we use? How to ensure that it can function more efficiently? So number one, we will say that we will use copper wires. So why? Because it has low resistivity. Okay. Number two, for the outside punya wire, we will try to use thicker wires. Alright, so why? So that it has lower resistance. Okay. Now, so why do I want to have lower resistance? Okay, in fact, I can add one more point to explain. So the lower the resistance, okay, watch how, right, sometimes when I don't know how to explain, I will use a relationship. I will use like a hubungan to explain this thing. So the lower the resistance, the lower the heat produced in the wires. Alright, so therefore there will be lesser heat loss. Moreover, I can also say that because my wires, when your wires has low resistance, you can say, so therefore there will be more current can flow into your kettle. Okay, so more current can flow into your kettle. So yeah, make sure you are aware of the answers, like how we can write this to become a better answer. So we got 4 points. So therefore these are the things that you have to focus on. Of course, there are other things to study in electricity as well, such as your EMF and your series parallel punya calculation. Alright, so I chose these few questions to discuss because I think it's worth discussing. Alright, so if you guys got no problem, so my episode will sampai sini sahaja for this one. Hopefully I'll see you in the next episode.